Hello, I'm Thomas Marshall Hill, and I'm here to present on a summer camp on the Ouachita River that I'm proposing to build using some hazard-resistant design. What I'm looking at building is something in about the 1,200 square foot range for maybe $140,000 on piers. All right, it'll be located, as I said, on the banks of the Ouachita River, which is in Ouachita Parish in the northeast corner of Louisiana, just outside of Monroe, West Monroe, Louisiana. All right, the hazards that I'll need to consider in this design, the most significant ones are wind, rain, and flooding. All right, the wind is in the 115 to 700 year design category, which is what most of the United States consists of, so there's nothing really out of ordinary with that. All right, so what am I going to look at for wind? There's a couple things. What I'm going to use is a standing seam metal panel system for the roof and for the walls, and build the roof on a 3 to 12 slope. The 3 to 12 slope, the steeper slopes have a tendency to resist wind, cut down the negative pressures that are placed on the top of the building as compared to a flat roof. Walls, 2x6 wall studs on 16-inch centers. That allow me to put some more insulation, but it will also beef that up using the same centers as if I would have had a 2x4 wall. Reinforced concrete piles, 14-inch piles are what we have used in the past for a lot of bridges around here, and so the height difference shouldn't be an issue here and should easily hold up this structure. The concrete will also resist any kind of rotting or termites. Open railing for the walkways to cut down any kind of wind drag on the walkway areas. Doors and windows will be built to meet the design, the wind design storm, and meet any kind of architectural or window requirements, window group requirements. Shutters. Shutters will be attached directly to the structural framing and not to the window or to the cladding on the outside of the building. All right. Rain. What am I going to look at for rain? Roof underlayment. I'm going to use that metal roof system on top of a 3/4 inch plywood, but all the seams of the plywood will be covered with that self-adhesive asphalt membrane. What happens is, if the roofing shingles or metal cladding gets blown away, then water enters through the joints on the plywood. So what this self-adhesive membrane would do would be to help wick that water off the roof until the storm went away and you had time to put the regular roofing materials back on. All the connections from the roof all the way to the piles, all the connections here will have some kind of stainless steel truss plates or rafter straps, and all hardware will be used to provide a continuous load transfer to the soil. Closed cell insulation will be used where possible to allow, if it gets wet, that water will leave, will get off of it quickly and not damage it. There will be a Type 2 30-pound felt used as a secondary watershed behind the metal panel system. All doors will swing outward, so to keep from wearing away the doorway, which will keep water from entering in case you got any blowing rains. All right, the biggest problem with this project is flooding, but I want a camp near the river, and so that's rivers rise, so these are my options. So as you can see here, this is the site. This is the floodway for the Ouachita River. Well, it's going to be outside the floodway, but it will be in the backwater locations. And the base flood elevation from the map is elevation 85. All right, there's a topo map. You can see this is the location, and it's located between topo elevation. There's an 80 in here, and then there's a 70 over here. So I'm saying somewhere in the neighborhood of 75. This is a shaded relief map. Just kind of helps you see these locations, and it'll help you see kind of the contours. Just a visualization of what those contours are and the elevation changes. All right, flooding. What are some things I plan on doing with flooding? Well, the biggest thing is I'm going to try to build this thing 5 foot above the base flood elevation. I'm going to try to build an elevation 90 for the design flood elevation, where the base flood's 85. When I first looked at this, I looked at the topo maps wrong, and I thought the natural ground was around 65. I missed one of the contour lines, but actually the natural ground's around 75. When it was 65, I was going, just going to put the camp about 20 foot above the ground, and elevating it any more than that would have been very costly. But now, since it's not going to have to be elevated as much, it looks like I can build that thing about 5 foot of base flood elevation and still afford to do that. Another thing is make sure you get these. We're going to get this HVAC system above that design flood elevation. Enclosures, no enclosures down in this area, just maybe some areas to park cars. That's all we can do. Those concrete piles, we're going to try to get those 20 foot in the ground to cut down any type of scour or erosion that could happen in case those velocities get built up during the flood. Floor joists here, we'll try to seal those, and we'll try to seal those with 3/4 inch plywood, so in case the water does get up and debris starts coming through here, it doesn't snag on the underbottom of the building. So in conclusion, what I'm going to try to do is build a 1,200 square foot camp, elevate it to 5 foot above the base flood elevation, and use some other techniques to help prevent damage in case you have some hazards such as wind, rain, or flooding. Some of those are not that expensive, but all of them seem like they'll be beneficial. Thank you.